We're going to take a look at this. Big shout out to Ryan, Miles, Tristan, and Randy. Okay. Hope you're doing okay. They're not going to watch us anyways, but they might. Now, just some general rules, and I actually, some might be new to you, but some might be common sense-ish. You'll see what it is. Order of integration. If I go from, and this is a definition, if I go from B to A, so from 2 to 3, and I get a area, that will be the same area except opposite sign as if I went and I switched the numbers. Do you notice? That would be from 3 to 2. You guys understand what that one means? If you just reverse the top and the bottom numbers, you have to reverse the sign in front of it. Does that kind of make some sense? I'll explain mathematics. What about the second one, the zero rule? Well, this should make some sense. If I go from 3 to 3, for example, from A to A, what's the area covered in this graph here under y equals 3? If I start at 3 and I end at 3, what's that strip of 0 width, right? It should be an area of 0. So if you have the same number to the same number, don't bother doing anything, right? It's 0. And I don't care what the function is in there. Next, constant multiple. So if you had a number like, and I don't care what the a to b is, 2 to 3, 3 to 7, but if you have some number and it's like 5x squared or something like that, that's the same as doing the integral for x squared here, but putting the 5 outside the integral sign. You'll get the same numerical answer. Does that make sense? Constant multiple. Okay? And same with negative signs. You could, if you have a negative sign that you could factor out of an expression, you could put it outside here and then just take care of it. Maybe it's easier to think about. That's really just a variation of something we saw before with negative areas under the graph, under the axis. Sum and difference. If you're taking the integral of something like x squared plus or 2x, let's say, that's the same as taking the integral of 2x, I did the order wrong here, sorry, x squared, and then 2x separately. Do that, do one integral at a time. Does that make some sense? It's like differentiating, right? You can go take care of each thing. Additivity. Now, if I went from a to b, and then b to c, so if I went the integral for the same function, by the way, from 2 to 5, and then 5 to 7, that will add up to the grand total of 2 to 7, that integral. If you take two small integrals, as long as they're connected, right, in the middle. That's all that one means. Max-min inequalities. If f, and if max f of the function, if the max of the function and the minimum of the function are maximum and minimum values of f on between two numbers, a to b, then let's take a look here. The minimum of that function on the interval b to a is going to be smaller than the integral at all other points, and definitely smaller than the maximum of that function. That seems, when you think about it, seems almost common sense, doesn't it? The minimum will be the smallest, the max will be the largest. Function values will either be equal to or in between those two values, right? That's what that tells you. Domination. If one function is greater than the other function on a given interval. So if I said something like, oh, it's a different color. So if I set up an axis here, and I'm just going to look at the one quadrant. If I say this is f of x, and I say it's always larger than g of x, at least I'm going to make it crisscross. At least on this interval from a to b, So it means nothing outside of this given interval. But I'm saying if f of x is larger than the function g of x, it should make sense that the area between a and b, for the blue function in this case, the top function, should be a larger area than that. Than the g of x on that same zone. That should make sense. Yeah, this is a small area. The other one's definitely larger. That's all that means. Okay? What else? Oh. If f of x is greater than 0, so if it's above the x-axis on that interval, your answer for the integral will be positive. It'll be greater than or equal to 0. Now that should make sense. We've actually talked about that too. So these are just general rules you should be used to. They're not used to, but just play around with. Now, let's take a look at this. We'll apply some of these. Well, let's take a look at it. Suppose that we're given a value for some function. It doesn't matter if it's x squared plus 5 or whatever, but the function between -1 and 1 gives me, the integral gives me 5. Okay? From 1 to 4, -2. From -1 to +1 for a different function, h of x, I get 7. Okay. From these three facts, not knowing what the actual equations are, what can we say about this? I look at this, and then I look at this. How are they different? What's that? Yeah, they're reversed. The second rule, was it? Oh, no, it's actually the order of integration, the first rule. I'll just erase these examples from there. Yeah, one's b to a, one's a to b. So 1 to 4, if I integrate from 1 to 4 and I get -2, it should make sense that when I switch this, 4 to 1, I should get opposite sign, yeah, +2. Okay. -1 to 4 then. This is set up in such a way that I start at -1, go to 1, pick this up at 1 again, and go to 4. Do you guys see that if you combine those two integrals? And if I wanted to show my work, I go like this. Well, this -1 to 4 is the same as -1 to 1 for the function, added to 1 to 4 for that function. Now, it seems trivial here to show your work like this, but I recommend you do for your note-taking purposes. And then it's just 5 plus -2. Because you might get something a little more involved than that. Maybe involving a diagram, etc. So, okay, the arithmetic, I guess the final answer is 3. Then, C combines a few rules. They're quite simple. Let's just see what this means. I could sort of think of this as distributing -1 to 1 for the f of x function and the h of x function, except that they're also multiplied. So there's the constant multiple rule and the, I call it distributing, but the sum and difference rule. So I could think of this, C, I'll do it in green, as 2 times the integral from -1 to 1 for f of x dx. I can squeeze that in there, so I'll move this down where I can do stuff better. Plus, I keep that sign, 3 times the integral from -1 to 1 for the h of x function. I have values for h of x and f of x in that interval, -1 to 1, integrated, now 5 and 7. So I just substitute now 2 times, that was the 5, 3 times the 7. The rest is just arithmetic. Be prepared, you probably will see things like that, and they don't seem too bad. 21 plus 10, 31. You see variations of these kind of questions. And and you'll see what I mean. So we've got a square root function. It's half of a sideways parabola. It should not be curving down. My knowledge looks like it's curving down. So still climbing. And from 1 to 4 is what I'm interested in. Now, use rule 6. That's that domination one. Well, this one here. I'll just go flip back to it in a second. The minimum on that domain, what was it, 1 to 4, and the maximum on that domain sort of sandwich in what the value of that integral will be. The maximum of the function times the range. The minimum of the function times, I said the range, the span of the domain. The maximum of the function times b minus a, the span of the domain. So let's just take a look here. I think you know this function well enough that you would say square root of 1 is 1. Square root of 4 is 2. Right? Now, what are we going to do here? So using this rule, it doesn't really help us a lot here, but it shows how it applies. The minimum of the function on that range, on that domain, 1 to 4, is 1. So the minimum times, what's b minus a is 4 minus 1, 3. That's going to be less than or equal to the integral from 1 to 4 root x dx, which is, the maximum on that function is 2 times b minus a, so 4 minus 1 is 3. All this tells us, in this case it's not really useful, but we are guaranteed things are in between 3 and 6. That's what it tells us for the value. Now you might be thinking, so? Well, you never know if some kind of problem solving kind of thing comes up. Does this make sense? Well, what we're saying is that if this is the minimum of the function, and if it never got higher than that, the area here would be this box, right? So I know for sure that the integral, the area underneath that curve, will be bigger than that. If it was a constant at a line equals 2, we would be calculating the area of this box. That box has an area of 6. And we know that the area of this function is less than that, right? That's really what you're saying. It's nothing of really any great consequence. But it leads into something called the average or mean value of a function. This will come off. Oh, did I? No, not me? Okay. Now, you will be specifically on AP quizzes and stuff like this asked to find the average or the mean value of a function. Okay? Mean value. If the function is integrable, meaning you can take the integral of it, it's continuous. If it does have breaks, maybe if it's a point break or something like this, no infinite discontinuities, you can take the integral of it. Its average or mean value on that interval from a to b is 1 over b minus a, then do the integral times that. Now, I say beside that looks like a tricky formula to memorize, but you really don't have to. You don't have to memorize this if you understand that it's really taken from the area of a rectangle. What do I mean by that? I'm going to just put this above here. If you have a function here, and if you could squeeze it above here, this is what I'm talking about here. If you have a function, say, some kind of quadratic kind of function. I don't care, it's some curvy. And from a to b, I can move it sideways, I guess, whatever. Anyways, it doesn't matter how you draw it. I'm just trying to emphasize that it doesn't have to start at 0. From A to B. So this is my A, this is my B. I'm going to take the integral of that. When you take the integral of something, what do you find it? The area. Okay. And what this is asking you for is the average height. Whatever this area turns out to be, I didn't tell you what the function is, so I don't know what it's going to be. You could make a rectangle of a certain height with the same base that will give you the same area. Do you guys follow that? What you're trying to find here, and we call it the average of the function. So the mean value of the function, the average of the function. Average value is, maybe in this case, it'll be a rectangle with this shape. What's under the blue would be a rectangle that gives us the same area as the curve does. You find? That's, first of all, what I want you to understand. Then, if I tell you this, then, the area, I'll do red for this, A to B for this function f of x. You guys said that this is the area, right? Now, maybe I should take my whole thing. My thing's getting too crowded. I'll put this over here. And it's not part of that example, but. So we know that this is the area. Maybe I'll write this above here. Area equals. Now in math talk, we'd say base times height, right? In this particular example, though, how big is the base? So if that went from 1 to 5, how big would the base be? The A to B? This was 1 and this is 5. You tell me this base is 4, right? B minus A. Always take the higher minus the lower. Final minus initial. So this is B minus A times the height. What did we label the height as here? Average. Bonds. So somehow, the average of the function. Do you see what I'm saying here? This is what this formula is telling you. The base times the height, which is the average height of the function, is the same as the area. And we know the area is an integral. Now solve for the average value of the function, and what do you have as an expression? So I'm saying solve for average. You got to divide by b minus a, don't you? This just turns out to be now, I've written it right to left. But would you agree what I have in this corner here is the same as that? Dividing by b minus a is the same as multiplying by 1 over b minus a? Now, the reason why I'm saying this is if you understand that area is given by an integral and that there's a rectangle for any given area, you can find a rectangle that has the exact same area. You understand how this formula, how you find the average value of a function. If you choose to memorize, that's fine. But if you're one where you're going to, just too much to memorize, as long as you understand that when you're talking about average value of a function, you're just finding the average height that will give you the same area. Area equals the base times the height. That's just isolated for the average height of the function. It's just a straight line. So, I'm going to move this again here. Oh. I'll just put this up here. Okay, find the average value of 2 minus x squared on the interval, 0 to 4. We're going to use your calculators. Get them out. And we'll just apply this formula, like I said. The average is equal to 1 over e minus a, the integral. In my case, we're going from 0 to 4 for the function 2 minus x squared dx. That's the variable. So we're trying this formula out. I think you can tell me right off the bat what b minus a is. 1 over, and it's 4, right? I should have put in 4 minus 0. It's 1/4. Your calculator is going to be used to calculate this part. I should have done this right off the bat. Does everybody know? And this is where Kayla's going to test how her calculator works. I think you should get negative 10/3 as the total answer when you multiply with the coordinates. Okay? Now, I want to make sure that everybody gets negative 10/3 with their calculators, and they know how to enter this integral. I'll pause the video here while you check. Okay, what we have at the top here now, you got the negative 10/3 out of the calculator, previous example. Isn't this just the mean value theorem that we saw previously? Average value of a function? Yes, it is. All this does is promise you, if f is continuous, there's going to be, on that interval, some part of the function that gives you a value c, we'll say, x equals 5 or whatever, on this integral that'll give you this average value, this mean value, right? That's all that says. There's going to be at least one point where you get that. So, you know how we said this area underneath what I just highlighted is going to be equal to what's in the rectangle here? There's got to be some point where it hits that line. That's all it says. And it could be 2 or 3 times, but at least once. Okay, we'll leave that. The derivative of an integral. Integrals. It's an antiderivative of a function. It's the opposite of the derivative, like multiplication and division. This means, okay, that's what I just said, I guess. Integration and differentiation are inverse operations. They kind of undo one another. Okay? So let's take a look at this then. If f is any antiderivative, now there's more than one possibility, and we'll see why, then the integral from a number, so 5, for example, to x, for that integral will be the antiderivative. The capital F will save capital F to usually use as an antiderivative, plus some number. Could be 0, could be negative 12, whatever. Also, for some constant c, some number, setting the x in this equation equal to a, what does that give us? Well, that'd be like going from 3 to 3 then, a to a. That'd be 0. And then we could figure out, isolate this. The antiderivative's value at that number a will be basically the negative value of the constant. It doesn't really make sense until we start playing around with this, and you will get a chance, okay? But putting that all together, this is important to you. Put a box around that, and that's what we're going to use from time to time, okay? So meaning that the integral of a function basically is the antiderivative with x plugged into it minus the antiderivative with some number put into it. I'm going to answer that. Here. Now, an antiderivative is the opposite of doing the derivative. Now, to do this one here, you know how if I said, what's the derivative? D by dx, I'll use this notation. D by dx of cos of x, what's that equal to? The derivative of cos of x is negative sine x. So similarly, the derivative of negative cos x is positive sine x, right? Now this is something we knew. Keep this. This is what I'm expecting you guys to sort of remember. And of course, the derivative of sine of x is cos of x, and so on. But here's what we're saying. Find 0 to pi, we're saying sine of x dx by using this formula. Now this doesn't go, that's from a to x, they say there. Let's just go from 0 to pi, right? If we think of an integral now, not just of area, but as the opposite, it's the antiderivative idea. What function, if you did its derivative, would give you an answer of sine of x? And you would tell me, sine of x is the answer when I did the derivative of negative cosine of x. You guys follow me on that? So the antiderivative, okay. So in this case, it would be the antiderivative negative cos of x. Oh, not of x though. Of pi in this case. So that's the f of x kind of thing. Minus the f of a. Well, in this case, it'd be the antiderivative, so negative cos of x, not x, cos of 0. Should have said. That's all this is telling you. And the arithmetic part of it, what's the cos of pi? And then take the negative sign. What is the cosine of pi? Usually, it is negative 1. And if you're wondering what the heck, you should know the shape of 0 to 2 pi, right? Knowing that pi is right in there for the regular cosine. That's the way I think of it. I say, okay, cos of pi is negative 1, but I have this negative sign in front of it. So I'm going to replace that with the double negative 1, so it's 1. Subtract. I'll see why. The cosine of 0 is positive 1. So when I put it in here, it's actually negative 1. Double negative minus negative 1, so it's actually adding 1. We got 2. Now, the whole idea there is that, do you see what the antiderivative is?
How could you find the antiderivative of some functions though? If there was like 4x, it could be 2x squared, or it could be...
This is perfect. It's just what we lead to on the next page. It is. Let's take a look at this. That's the question I've been waiting for. So what does this really mean? F is any antiderivative of that. Big F, antiderivative of little f. The function given, like you said, 2x or something. Hey! Now, when we say, and there's a reason why we say any antiderivative, there's more than one antiderivative. Why? Well, look at these when we do differentiating, f of x. X squared gives me 2x when I do the derivative. But so does x squared minus 5. So does x squared plus 9. So if I say, what's the antiderivative of 2x? It's going to be x squared, but I don't know if it came from x squared plus 0. I don't know if it came from x squared minus 5 plus 9, a billion, and so on, right? So this is why we say x squared. That's the part I do know for sure. But I don't know if there was something added on. We have to include this plus c part because it means any constant. As you see above, there's a variety of functions that can give you a derivative equaling 2x. So we don't know for sure what the antiderivative is. But the answer to this problem, if this was like from 5 to x, it'll be x squared plus some constant. It'll be the same constant if you had like from 3 to x, so on. So, we've got to think of these antiderivative parts, okay? There's some antiderivatives you just need to know. So the antiderivative part is the x squared part, and then the constant. So the trig functions, as we mentioned, sine and cos, those are just knowns kind of things. But what we were asking earlier was, well, let's take a look. If the derivative answer was, now I've got this in reverse, right? I'm giving the derivative column first. What was the original function that gave me? Well, I know the power would have been higher, right? The derivative of something x to the 4 will give me an x cubed. How do I get 1x cubed out of this? 1 over 4. Okay. X squared would have come from x cubed something, right? Oh, can't do that. Said the right thing, didn't do it. But when I do the derivative of x cubed, I need to get rid of the 3, so 1/3. If I do the derivative of what's in green, I'll get x squared, right? If I do the derivative, what would give me x? A single x, I know the power was x squared, but I have to get rid of that number. So if I did the 1/2 x squared's derivative, I'm going to get x. So these are the antiderivatives we're coming up with, right? What you could have started with. Now there's a reason why I do this one here. Instead of just saying 1, think of it as x to the 0. What did that come from? Well, the derivative of what gives me 1? X, right? Same pattern. I'm not going to put x to the 1. Okay. The derivative of what? Now this one's tricky. This means 1 over x, right? Now, if I'm following this pattern, I go 4, 3, 2, x to the 1. But we can't have x to the 0, right? Because that would be a constant. And the derivative of a constant is just 0, right? What was it that we take the derivative of that gives us 1 over x as our answer, x to the -1? Do you guys remember?
Natural law.
Hey, you do remember. The natural law. That's a stumper at first. If you do the derivative of the natural law, 1 over x. The antiderivative of 1 over x, natural law. Then from there, our pattern resumes. You got x to the -2. You must have had x to the -1 first. Now 1 over -1 is the fraction. I'll just call it negative. That derivative. You guys follow that? Same pattern for everything else. Push up, x to the -3 must have come from 1 higher, x to the -2. But this time, I'm going to show it as a fraction. These are all the antiderivatives. So if you're asked just for an antiderivative, it's what was it that I did as a derivative that gave you that answer? Okay? Now, I pushed through everything. So you could try all of these. Hint for number 27, don't worry about number 27, okay? I'm looking at that, that's junky. Like, I'm not confident that anything like that would be on the AP thing. Sorry, you were saying?
So we put plus C on all of those, or no?
If I'm just saying the antiderivative, we can just say the 1/2 x to the -2 and so on. Plus C is if I'm actually doing the indefinite integral or the actual integral. So here's what you're getting at. Can I have this above here? Yeah. This is the full answer to this integral, right? I say, the way I use the language, this is the antiderivative plus the constant. That's the way I'm looking at it, okay? And that's the way I'll use the word. I don't know if there's an official definition of the word, if it has to include the plus C. However, if you're doing an integral from a constant to an x, you're going to have that plus C, okay? Because you don't know what the number was. Now, I'll turn you loose on these questions, and we'll take a quick look. I'll just